Welcome to our first thermochemistry video on heat. What is heat, first of all? Heat is the energy change in a process and is symbolized by the letter Q. Heat flows in a certain direction. It flows from higher to lower temperature objects. For example, if you were to leave an ice cube out on a table, over time it will melt because the energy from the environment will flow into the ice cube to melt it. Similarly, if you leave a hot cup of coffee on the counter, it will eventually cool down because the heat from the cup of coffee dissipates out into the environment. Heat can be measured in two units, in calories or joules. 1 calorie is defined as 4.184 joules of energy. These are both ways to communicate energy, just in different units. In order to correctly identify the direction of heat flow, we must first identify and define something called the system and surroundings. So the system is what we are looking at. It is a part of the universe that is being studied. The surroundings is everything else in the universe besides the system. Here are examples of 3 types of system. We have 3 different types of containers that are filled with water, and the first one is an open system. Because it's an open system, there is an exchange of mass and energy with the environment. The water can leave the container, and so can the heat. The heat can be leaving the container or being absorbed by the container of water as well. The next system is called a closed system. It is closed off, so only the energy, the heat, can be absorbed by the system or leave the system. It's closed off, so none of the water can leave the container. The last system is an isolated system. There's a layer of insulation around the container and it is closed off. Because of that, nothing, no mass or energy can be exchanged within the system and the surroundings. So depending on the direction of heat flow, it can be described as either an endothermic process or an exothermic process. Let's start with the endothermic process. Endothermic process describes when heat enters the system from the surroundings. In other words, energy is absorbed by the system. The sign convention that we use for the letter Q is that it is positive. Q is greater than 0 and it is given the sign of positive. For example, let's take a look at this example. If we were to dissolve ammonium chloride, solid ammonium chloride, into its ions, ammonium ion and chloride ion, it will actually absorb heat from their surroundings. If we were to do this experiment in a beaker, how would this beaker feel on the outside? It would actually feel colder. The reason why is this reaction is absorbing heat from the surroundings, which includes your hand, and the energy leaves your hand into the surroundings, into the system, and it will feel very, very cold. Energy, let's take a look at the energy of this reaction. So the ammonium chloride, let's say it starts off at a certain level of energy in solid form. As it dissolves into the aqueous form, it actually absorbs energy, like we said, and it enters a higher energy state as ions. It gets very, very cold. In fact, if you were actually to take this container of ammonium chloride, dissolve it, and place it on top of a wood block that is coated with some water, it will actually freeze that water on that wood block. Because it is so endothermic, it will absorb so much energy from the water that it will actually freeze that water. So it gets very, very, very cold. An exothermic process is the opposite. We have heat exiting the system, energy is given off to the surroundings. The sign convention is that Q is a negative number. For example, let's take a look at the dissolving of calcium chloride. Much like the last example, calcium chloride will dissolve into its ions. It will form calcium 2+ ions in this case and chloride ions, and heat will be produced. So if this reaction were to happen in the beaker, how would it feel if we were to touch the outside of the beaker? It would actually feel warmer. The reason why is because let's say that this calcium chloride starts off at a certain amount of energy. When it dissolves, it will decrease in energy. It will release that energy out in the form of heat into the surroundings. And what's left is a lower energy state for these ions. In fact, calcium chloride produces so much energy, it's often used as a de-icer for driveways. If a driveway is covered in snow and this ice needs to be melted, often the calcium chloride will be sprinkled on a driveway, and the dissolving of this calcium chloride will actually produce so much heat that it will melt the ice on the driveway. let's take a look at ice melting, which is an endothermic process. So from solid form to liquid form to melt ice, heat needs to be absorbed for this process. And energy is a positive value since it is being absorbed. So let's take a look at this video of what happens to water molecules as ice melts. So in ice form, the water molecules are structured in a way that's very patterned and they are vibrating in place. As energy is absorbed, however, the motion of the molecules starts to increase. It starts increasing until the motion of the molecules overcomes the attraction between the molecules, and then the ice will melt. So in summary, during the ice melting process, energy absorbed, which weakens the attractions or hydrogen bonds between the ice molecules. And it weakens so much that the bonds break between the molecules and they are free to move around in the liquid state. Let's look at the freezing of water, which is an exothermic process. From liquid water to solid form, heat is released in this process. And Q is a negative number since we have energy being released from the sample of water. So let's take a look at this video real quick. Here we have liquid water, and as heat is being released from the sample of water, so we see here, the attraction between the molecules will overcome their motion as the molecules slow down significantly and the water freezes. Interestingly enough, when molecules freeze, they arrange themselves in this repeating rigid structure. As you can see in this picture here, liquid water, very disordered, but in ice form, actually the water molecules align itself into this nice rigid structure. So in summary, energy is released during this freezing process, which strengthens the attractions between the water molecules, which allows them to form bonds between each other into this nice ice formation. So here we go. Today we just talked about just generally what is heat, and that's the end of the lesson.